Hello students, welcome to our fourth lesson on circle theorem. Now in lesson 3, we looked at the second theorem where we saw that in the second theorem, when a chord forms an angle at the center and the same chord forms an angle at the circumference, then the angle at the circumference is half the angle at the center, or the angle at the center is twice the angle at the circumference. So we solved one example and it was left for you to do yours. Okay, so we'll start today's lesson with a question where you will try your hands on for the second theorem. So let's look at the question. So I'll call Matt. Then we are still on circle theorem. So example 2. So this will be example 2 on theorem 2. Example 2 on theorem 2. So let's look at the question. In the diagram below, O is the center of the circle. O is the center of the circle. In the diagram below, O is the center of the circle. Now, the question is find angle X, Y, Z. So in the diagram below, O is the center of the circle. Find angle X, Y, Z. Find angle X, Y, Z. So now let's look at the diagram. So this is our diagram. We have a chord here, our center. The question says is O. Good. So this is our Y, this is our Z, and this is our X. Good. So in the diagram below, O is the center of the circle. Find angle X, Y, Z. Good. So try your hands on this in the next 2 minutes. When you are done, I'll help you solve it and you compare your answer with our solution. Okay, so 2 minutes, start work. Okay, so now let's look at the solution to this question. Let's look at the solution to this question. Good. So the question told us that we have to find angle XYZ. So solution. We have to find angle XYZ in the diagram. We have to find angle XYZ in the diagram. So let's go back. Good. So in the diagram below, O is the center of the circle. Find angle XYZ. So the first thing is that anytime you have the diagram, you have to observe or identify the theorem in the diagram. So with this question, we can identify the second theorem that we learned, whereby this chord XZ formed the angle 120 degrees at the center here, and the same chord XZ is forming an angle Y at the circumference. Okay, so now this diagram depicts the theorem 2. So it means that from the theorem, this angle here, this angle 120 degrees here is twice this angle here at the circumference. So angle XOZ should be equal to 2 times angle XYZ. Okay, so angle XOZ should be equal to 2 times angle XYZ. Good. So let's look at the solution again. So now angle XOZ should be equal to 2 times angle XYZ. So substituting, angle XOZ was given as 120 degrees, and this will be equal to 2 angle XYZ. So we are looking for angle XYZ, so we divide both sides by 2. So we have 120 degrees so this over 2, this over 2. So now we are going to have 60 degrees is equal to angle XYZ. So this will cancel this, this will cancel this. Okay, so therefore angle XYZ is equal to 60 degrees. Angle XYZ is equal to 60 degrees. So that is the solution to the question. So you realize that this question, the diagram or the angle has been tilted to the side. In the example that we, the first example, the angle was at the upper part, upright. So you should realize here that no matter where the direction of the diagram will go, your aim is to just identify the theorem in the diagram, then you apply it to solve it. So don't be bothered where the direction will go. If the direction is up, down, side, whatever, your aim is to identify what the theorem. Okay, good. So now let's move on to our main lesson for today. So let me give the title again. So still circle theorem. So this will be theorem 3. Theorem 3. So let's look at what the theorem says. So we have our circle. This is our circle. Then we have a chord here. So let's label it A and then B. So now you realize that this chord AB has divided the circle into 2 parts. This upper part, that is the bigger side, and then this lower part, that is the smaller side. Now we call these parts segments. So the bigger part is called the major segment, and then the smaller part is called the minor segment. So bigger part is called major segment, smaller part is called minor segment. So every chord divides a circle into 2 segments. So if one side is bigger than the other, then we'll have major and minor. But if we divide it equally, then we'll just have segments. Okay, So one will not be bigger than the other, so they will be the same. Good. So now the theorem is saying that if this chord AB forms an angle here at the major segment, okay, so let's label it as C. So if this chord AB forms an angle at C here, and the same chord AB forms an angle here at this side of the circumference. So let's label that one also D. Okay, so chord AB formed angle C, and the same chord AB is forming angle what? D. So the theorem is saying that if a chord forms an angle here at this side of the circumference, and the same chord forms another angle here at the same segment, then the angle here and the angle here are the same. So the angle at C and the angle at D are the same because they were all formed from what? The same chord. So chord AB formed angle C, the same chord AB formed angle D. So once the angle D and angle C were formed from the same chord, they are the same. So that is basically what Theorem 3 is about. So now let's put it down in a statement. So from the explanation given, in your own words, write the statement down to describe this theorem, Theorem 3. Write it down in your own words. How will you describe this theorem? Okay, so let's look at how we can write. So now we can, from the explanation, say that angles formed by a chord, angles formed by a chord at the circumference, so angles formed by a chord at the circumference, angles formed by a chord at the circumference angles formed by a chord at the circumference on the same segment, So angles formed at the circumference on the same segment. Angles formed by a chord at the circumference on the same segment are equal. So let's take it again. So angles formed by a chord at the circumference on the same segment are equal. Angles formed by a chord at the circumference on the same segment are equal. So it means that if this place is X and this place is Y, then X is equal to what? Y. X is equal to Y. So angles formed by a chord at the circumference on the same segment are equal. So students, this is how far we'll end today's lesson. The next time we'll meet, we'll look at Theorem 4. So keep on revising, keep on reading ahead. We'll meet again next time. Thank you.